Hello! Welcome to another video from DFS on technology. In this video, I'm going to talk about Mailmunge. Mailmunge is an email filtering framework for Linux that lets you write your email handling policies in Perl, making it very easy to come up with creative and sophisticated email filtering. I'm going to talk a little bit about how email is delivered on the internet, and then I will talk briefly about Milter, which is the technology Mailmunge uses to integrate with Postfix or SendMail, which are two very popular email server programs on Linux. For most of the video, though, I'm going to show you how to write filters using Mailmunge in Perl. So let's get started. First of all, we need to know how email is sent on the internet. When a machine wants to send email to another machine over the internet, it uses a protocol called SMTP, which stands for Simple Mail Transfer Protocol. This is a line-oriented, human-readable protocol that runs over TCP, typically on TCP port 25. Now, in this video, I'm not going to get into how a machine knows which machine to connect to deliver mail for a certain email address. I'm just going to assume that it has found the correct machine. The machine that is sending the email is referred to as the client, and the machine that is going to accept the email is referred to as the server. So in the next part of the video, I am going to pretend to be an SMTP client. I'm going to run the SMTP session by hand, and I will run it against a Postfix server, Postfix being a very popular email server program for Linux. And this will give you a flavor for how SMTP works. So let's go ahead and take a look at a typical SMTP session. Okay, let's have a quick look at a typical SMTP session. I'm going to run the session by hand with the telnet command. I'm going to telnet to that machine on port 25. So I'm an SMTP client. I connect to the server, and the server answers with a single line banner. This is this line right here. The first three digits are a code, and a code that starts with 2 means success. So that means we're successfully connected to the server. At this point, the client is supposed to identify itself with a hello command, so let me do that. So I say to the server, hello, I'm a client, and the server replies with another reply code beginning with 2, which means everything's good. Next, the client says who the mail is from, so I always say mail from user3@example.com. So the server says, yeah, okay, I'll accept mail from that user. Next, the client has to say who the mail is for. So let's say it's for user1@example.org. And let's say there's somebody else copied on this mail. So there are 2 recipients. Receipt to user2@example.net. And the server says, okay, it's willing to accept mail for both of those recipients. At this point, we've given the sender and the recipients, so now we actually have to send the email itself. So we say data. This tells the server, I'm going to send the actual mail body. And the server replies with a 300 reply code, which means, okay, send the body. And it asks you to end it with a carriage return line feed, a dot, a carriage return line feed, which essentially means just put a dot on a line by itself when you're done sending the mail. So we'll send the mail. We'll say it's from user3@example.com to user1@example.org. Well, let's pretend user2@example.net is BCC'd, so it doesn't appear anywhere in the headers. We'll give our message a subject. So those are the message headers that you see in your mail reader. We enter a blank line to delimit the message headers from the message body, and then we transmit the message body. Hello. So let's say that's the entire message. We then put a dot on the line by itself to tell the server that we're done. The server thinks for a little while, a long while, and says, fine, I've accepted the message. And it also tells you the queue ID so that email administrators can go looking in the logs to find the message if necessary. And now let's say the client has no more email to send, so it says quit. And the server says bye. And we've just sent email over the internet. We're now going to take a look at an SMTP session with Mailmunge in the mix via the Milter interface to postfix or sendmail. As usual, at the beginning of the SMTP session, the client connects to the server. But instead of replying right away, the server consults Mailmunge to see what its reply should be. It ends up calling a function called filter connect in your Mailmunge filter. This is past the IP address of the client. If your filter decides that it doesn't want that client to connect to the server, it can instruct the server to fail the connection attempt rather than to let it succeed. For now, we'll assume it succeeds. Next, the client sends its hello command. Again, before replying, the server consults Mailmunge to see what it should do. In this case, it calls a function called filter hello and passes in the argument to the hello command. Once again, if your filter doesn't like what it sees, it can fail the command. Similarly, when the client sends the mail from command to tell the server who the sender is, Mailmunge is consulted, a function called filter sender is given an opportunity to modify the server's reply. And for each recipient, a function called filter recipient in the Mailmunge filter is called to allow Mailmunge to decide whether or not recipients should be accepted. The final call into the Mailmunge filter happens after the entire message has been transmitted. In this case, a function called filter message is called, and it's passed the entire mail message. Not only can filter message change the reply code, in other words, it can fail the sending of the email if it wishes, but it can also do other things, such as change the message sender, add or remove recipients, add or delete or change message headers, or even replace the entire message body completely. We're now going to take a look at our first Mailmunge filter. This is a very simple filter. Now, I'm not going to go over how to install and configure Mailmunge and the email server program, in this case Postfix. All of this information is available in the Mailmunge documentation. We'll just assume that Mailmunge is compiled and installed and configured, and we'll take a look at the filter. Now, the Mailmunge filter lives in a specific place in etc mailmunge filter.pl, like this. So let's go ahead and take a look at that file. This is a normal Perl program. You can see from the first line that it is run using Perl. We put all of our filter code in a nice package, typically a package under the Mailmunge filter namespace. In this case, it's Mailmunge filter example 1. Always use strict and warnings in your Perl code because that catches a lot of errors. Now, this is a very important part. We use the base class Mailmunge filter compat. That means our package inherits all of the methods of Mailmunge filter compat. And you need to use that base class or just Mailmunge filter in all of your filters. We're also going to bring in a package called Mailmunge response, which is how the filter responds to an SMTP command. So let's take a look at this simple filter, which only defines filter recipient. Now you may recall this gets called after the receipt to command has been given by the client and before the server replies. This method gets passed two arguments. Self is just the Mailmunge filter example1 object, and CTX is a context object that holds all the information about the current callback. I'm not going to get into it in detail. All the documentation is available. The important part of the method is this if statement. So basically what it does is it says if the first recipient, which in the context of filter recipient is the only recipient, if the first recipient is bob@example.org and the sender is not equal to jane@example.net, we respond with a reject and the message, you are not allowed to email Bob. Otherwise, we say continue, which tells the MTA to accept the command. So in a nutshell, what this does is it only allows jane@example.net to email Bob. It doesn't allow anybody else to email Bob. The last few lines are boilerplate that have to appear in every Mailmunge filter. This line here creates a Mailmunge filter example1 object, and this line here starts the filter running. Those lines are always the same. So let's take a look at an SMTP session with this filter in place. So I'm going to telnet to the mail server and give a hello command. It says hello. I'm going to send mail from outsider@skull.ca. And then I'm going to say receipt to bob@example.org. And you can see here that the MTA is told to reject that receipt command. And you can also see that it says, you are not allowed to email Bob, which is the error message from the filter. Let's reset things and try again. So this time I'll say mail from jane@example.net. Receipt to bob@example.org. And you see that time it was accepted because the filter was told to accept mail for Bob if the sender, and only if the sender, was jane@example.net. We're now going to take a look at a more complicated Mailmunge filter. This one does content inspection as well as content modification. So let's go ahead and look at the filter file. It starts with the usual package declaration and use of the base class. Oh, use Mailmunge responses in there twice. That's a typo, but it doesn't really matter. And we use a couple of other Mailmunge classes that I won't get into in detail. You can see the documentation, as well as a module called File Virus Scan, which is available on CPAN, and this does virus scanning using various virus scanning engines. So let's take a look at the filter. The only method defined is filter end, and this gets called after the message has been transmitted, but before we've replied back to the SMTP client. So again, as usual, this method gets passed two parameters, self being the filter object itself, and CTX being a context object that holds all of the information related to the callback. So the first thing we're going to do is scan for viruses, and that's this code here, so up until this line here. I'm not going to go into it in detail, but basically we create a file virus scan object. You can read the documentation on CPAN. And the engine that we're going to use is the ClamD virus scanner. This is an open source virus scanner. And we have to pass a parameter to the engine, namely the socket name. This is the socket on which the virus scanner daemon is listening. So this is just basically boilerplate setup stuff. Then we scan the input message. So the virus scanner wants an absolute path name, which we can obtain using this method on the filter. So we tell it to scan that file. We get the results. Now, we get a list of results because in general you can scan with multiple virus scanners. In our case, we're only using one, so we get the first result back. If the result is an error, and this can happen if, for example, the virus scanner is not running, if it's an error, we temp fail the message. Otherwise, if we got a result, we reject the message with the failure message found virus and the name of the virus. So that's the virus scanning. Let's look at the next bit of filter end. That's this part. This is spam scanning. All of that code. So here we create a spam assassin test object. In Mailmunge parlance, a test object is something that looks at the content of a message and gives you an answer about it. In this case, we're going to look at the message to see if it's spam. So we create our object, we run the object against the message, and if we get a status back, which we always should, first thing we do is we add a header called xspam results. We give the score and the list of tests that were hit, and you'll see this in action later. Then we make some decisions. So if the score is greater than or equal to 8, we actually bounce the message with a failure, sorry, but your message is simply too spammy. If the score is greater than or equal to 5, so in other words, it's less than 8 but greater than or equal to 5, we change the subject to prefix it with this little spam in square brackets. And we also add a header, xspam status, yes. Otherwise, so over here we scored less than 5, we delete any existing xspam status header because a mail could come in with that header already in place and we don't want it there if it's not spammy. This statement here simply releases resources. It's required by the spam assassin code. And then the final part of this filter shows you an example of message modification, where we add legalistic boilerplate to the end of the message. We create a Mailmunge action boilerplate object. And again, just like a Mailmunge test object looks at a message and tells you something about it, a Mailmunge action object does something to the message. It changes it. So in this case, the boilerplate action lets you add boilerplate to the message, as you might expect. So we create our object here, and then we add text boilerplate to the message. Here is some annoying legalese. There are corresponding methods to add HTML boilerplate to HTML message parts. As you can imagine, that's a bit more complicated than adding plain text because you can't just append it. You have to add it in the right place in the HTML. So all of the HTML parsing logic is implemented. Anyway, that's the filter. Then we have our usual create the filter object and run it boilerplate. So let's take a look at this filter in action. We'll telnet to our mail server as usual. There we go. And I'm going to start by trying to send a virus. So I'll do the usual hello localhost, mail from. So all of this should look pretty familiar. I'm now just going to grab a message that contains a test virus. So we'll transmit that. This line here is called the iCar test. It's a standard test vector that all antivirus programs are supposed to recognize. So we'll send our message, and there you can see the filter rejected the message. That's a 500 failure code. And it says, I found a virus, and it tells you the name of the virus. So the antivirus part works well. Now let's send a very spammy message. So again, I'll just cut and paste. And this time I'm going to send this message. This line here is a test point for anti-spam programs. An anti-spam program is supposed to detect that and score the message very highly. So let's try to send that message. So we'll send our dot. And here you can see that the message rejected it. It says, "I'm sorry, but your message is simply too spammy." Now let's send a slightly spammy message. So we'll redo our SMTP session. And this time, I'm going to send this message. Now you can see the subject has this weird phrase, 5 points. I've created a custom spam assassin rule that scores at 5 points. So this message should score somewhere between 5 and 8 points. So let's send that message. And you can see that it was accepted. Now I'm going to grab this QID. And look at it in the mail log. So let's take a look. So there you can see the logs from Mailmunge. It changed the header, X spam results, score equals 5, and the list of tests. That's the test test rule that I created just to make this score 5 points. You can also see that it changed the header to include the spam tag. And you can see that it added an X spam status yes header. Now I've created rules that end up delivering the message in a place we can look at. So let's take a look at the message. So you can see some headers added by the MTA. You can see that the subject was tagged with spam. So that worked. You can see our X spam results header got added. You can see our X spam status header got added. And finally, you can also see the annoying legalese that got added at the end. Well, there you have Mailmunge in a nutshell. I hope you enjoyed this video. Please go to www.mailmunge.org and read the Mailmunge documentation, download it, play with it. If you like the software, please subscribe to the mailing list and join the Mailmunge community. I hope you have many happy filtering hours ahead of you. Thank you for watching. Please hit like, please subscribe to my channel, and I'll talk to you next time.